Good afternoon and welcome to our video explanation of the characteristics and classification of BIM's standardized profiles. In this video we will explain to you a lot of information of these profiles. I hope that the information is enough to understand everything about what I just said. Well, let's start with the structural profiles or BIMs. These profiles or beams are a type of products that are created by hot rolling of steel, also called rolled. Furthermore, they are divided into two types by their process, hot and cold, and both are used for the construction of works and structures, but they depend on their time and function. The type of profile the steel beam is to have, as well as its qualities, are decisive when choosing them for application and use in engineering and architecture. Among its key properties are its shape or profile, its weight, its peculiarities, and the chemical composition of the material from which it is made and its length. The structural steel profiles are chosen according to the magnitude of loads to be resisted, the way of working such as tension, compression, bending, torsion, among other specific characteristics. These um, um, these characteristics or these magnitudes of loads are the ones that we have been seeing in all the quarter. So I think that we are uh, familiar enough with these characteristics. So um, among other specific characteristics, uh, to join structures and appearance in buildings, according uh, to the Cámara Mexicana de la Industria de la Construcción, or Mexican Chamber of the Construction Industry, CMIC, the structural steel profiles available in Mexico are used for the design and construction of buildings and are designated based on the EMCA nomenclature. That there's a lot of information, but well, let's explain more.
According to the AISC and the NTC 70, there are two types of profiles, slim or not slim. This will depend of the width to thickness ratio. For the web, the relation is the cant divided by its thickness, and for the flanks, it's the half of the width of the flanks divided by the thickness of it. In case of the width to thickness ratio being higher than the limit, it will be considered a slim profile. Otherwise, it would be a not slim profile. The limit to identify the type of profile is obtained through a formula that is going to be applied in the different areas of the beam.
UPN steel. Profiles of this type are designated by the letters UPN, followed by a number representing the total nominal height in millimeters. This type of profiles are used as supports and pillars by welding the ends of the flanges. Now we have IPN steel. It is a profile whose section has a double D shape. Its thickness is called normal. The other faces of the flanges cross the web perpendicularly, and the inner faces have a 14% inclination. In this case, their thickness decreases towards the edges. The joints between the inner faces of the flanges and the web are rounded.
IPS steel, also known as double T profile, and this thickness is known as European. It comes from its faces, both exterior and interior, as parallel to each other, being also perpendicular to the bed with this tippet of the profile characteristic by the constant thickness. The ratio between the width of the flanges and the height of the profile must be less than 0.60. EV steel. The EV steel profile is a H-shaped and is of the normal series. Other an interface of the flyers at parallel to each other and inter and perpendicular to the web, so that in this case in the flyers have a constant thickness. Is main application is industry and civil construction of the buildings, frames, truss, bench, columns.
HEA steel. This profile is a light series. It has outer and inner faces of its wings parallel to each other, being perpendicular to the web as well. Like the previous profiles, its thickness is constant. These profiles are mainly used in industry and civil construction of buildings. They are also often used for infrastructure and automotive construction. HEM steel. The HEM steel beam has outer and inner flange parallel to each other and perpendicular to the web. The joints between the web and the inner faces of the flange are also round. The main application of the HEM profile are the construction for lintels, structural reinforcements, purlins, structures for stairs, and for machine construction.